So we've defined this new type of function, namely the hyperbolic functions, but we haven't actually done any calculus yet. Well, that is about to change. In topic 3, we're going to differentiate and integrate hyperbolic functions. Now, as per usual, with weird functions like this, we're not going to expect you to memorize, say, all the derivatives. But there they are in their lovely glory. So let's start with derivatives, and then we'll move into integrals. All right, so for the derivative of x sinh x minus cosh x, well, the product property, quotient property, all those properties still hold. So you can see for this particular piece, that's x times the sinh of x. So that's going to need the product property of multiplication, or of derivatives, to the derivative product property. So therefore, y prime of x would be equal to, the derivative of x is 1, and then leave the sinh alone, plus leave the x alone, and the derivative of sinh is cosh, minus, and then the derivative of cosh is sinh. So the derivative of sinh is cosh, the derivative of cosh is sinh. There's no negatives on these ones for sinh and cosh, unlike regular trigonometric functions. So this will be minus sinh. Now, if you're noticing what I'm noticing, we have a sinh here minus sinh here. Those will disappear, and we'll just be left with y prime is equal to x cosh x. Well, that was easy. No problem on that one. Just a little product rule. We didn't even have chain rule on that one. But the next one's going to involve chain rule. All right, so you can see we have one function nested inside another function. All right, so that's the little one, that's the inner function. If you will, it's the u. If you look up here, they're assuming you're going to use the chain rule all the time. So they're assuming that u of x is equal to x over 36. And you can see we're going to need u prime, right? U prime is in a lot of these. So as a matter of fact, we're particularly interested in arc-seq, excuse me, which is down here. So you can see there's a negative u prime in there. So we're going to need that. So let's go find it. U prime of x will be the derivative of x over 36. So u prime of x is du dx, which is 1 over 36, because this is x to the 1. If you like, this is 1 over 36 times x, right? So then this would just be 1 over 36. Okay, so then now let's find the derivative. Y prime of x would be equal to, and I'm going to use this arc-seq formula right here. So it's negative u prime over u times the square root of 1 minus u squared. So that's going to be negative. For u prime, I'm going to have 1 over 36. And then over u is x over 36. Oh, I forgot the 36 in front of the whole thing. Rats. Let me put, you know what, here's what we'll do. We'll do negative 36 times, and then I'm just going to put a u prime down here. I'm going to use the second version right here. So instead of 1 for us, it's 36 because there was a 36 in the whole problem. So, and then I'm going to multiply by 1 over 36 at the back end here. Just to make sure everybody's really clear on that one. That 36 is coming from here. That's why that's 36. My pink isn't showing up. There we go. Okay, so then it's u prime right here, u right here, big square root, 1, take away, and then it's x over 36 squared. Okay, a couple things. This 36 and this 1 over 36 are going to end up canceling, so that's no problem. This is 1 divided by x divided by 36. So this little 36 here is going to end up back in the numerator. So it's going to be equal to, I'm just going to put it over here, negative 36, and not because of this 36, but because of that 36 right there, because these 36s went away, right? Or if you like, you could say that 36 cancels with that 36. One way or another, one of them is going to go and one of them is going to be left. So it's 36 in the numerator, And then we're going to have x out in front. So that x right there, right here. And then let's think about this. I want to combine like terms, right? If I want to make this go together. So I'm going to rewrite that 1 in a very smart way. I'm going to make it 36 over 36. Here, I'm going to make it 36 squared over 36 squared. That way they'll have the same denominator. So this will be x times the square root of, and then it's 36 squared minus x squared all over 36 squared, because I made them have the same denominator. Okay, well, let's see here. That's negative 36, x out here, and actually a 6 out here, because the square root of 36 squared is, 36, sorry, 36 here, because it's the square root of 36 squared. So that's a 36 right there. And then what's left inside here is a square root of 36 squared minus x squared. Okay, so then again, we have a 36 in the denominator. So this makes it negative 36 squared over x square root 36 minus, or 36 squared, sorry, minus x squared. That is the derivative, believe it or not. Right? This 36 right here, because it's in the denominator gets flipped up and is in the numerator, and that's why that's squared. There's a 36 already there, and then another 36 joins him. Now, technically, you could rationalize, but I mean, why bother? Well, all right, you talked me into it. If you want to rationalize, you multiply both sides, or both the numerator and denominator, by that square root. It'd be negative 36 squared times the square root of 36 squared minus x squared, all over x times 36 squared minus x squared, like that. And, you know, if you're tempted, you can find what 36 squared is, you know. It's not going to really change the bulk of the problem, though. So it was a chain rule, and it was a tricky one, right? So we had to use this formula. The formula actually has chain rule figured out in it. We actually didn't use this one, this version of it. It's the same formula, but we used -1 times u prime. That's kind of the version we used, because that's the u prime right here. Right there. And then this is the u, and that's the u squared, and so on. The 36 came from the fact that we multiplied the whole thing by 36. And then after that, it's just some algebra simplification.